about quantum computing today, tomorrow, and you. My voice is a bit husky today. I've got cough, so I'll be quite audible. Can we go to the next slide? Yes. So quite a good number of you might have seen this image before. Most of you might have heard about quantum. You might definitely know what computing is and all the other keywords in the topic. But then that of quantum might not be that familiar with. So quite a good number of people. Okay, great. So usually I would have gone through the slides by myself, just going next by next. But then what we have is that we've seen some clips, that's some images based off the movie Avengers Endgame. And to quite a good number of you who might have seen that movie, that might have been where you've heard the word quantum. So the first slide was them going through a time machine, which is based off the principles of quantum, and then they were able to retrieve the 6 infinity stones. Now, what's quantum computing? Quantum computing is based off quite a good number of quantum mechanics principles, which is the superposed entanglement and then the non-deterministic outcomes of the state of the machine. The most basic building block in quantum computing is the qubit, and this qubit does not have a particular state. That is, the state of a qubit is based on the linear combination of the kind of states that is there. Okay, so the next slide, please. So you might have seen this machine. This is also in a movie. And then if we are to go to the next slide, you would recognize the character there. That is Courtney, aka Ant-Man, right? So we have Ant-Man in a probabilistic storm, having himself replicated in various forms. And then if we are to go to the next slide, this is the whole combination of Ant-Man going to solve a particular problem. That is shrinking the energy core of Kang's machine. This was all taken from the movie Ant-Man and the Wasp. So, looking at quantum advantage, all companies want to achieve quantum advantage right now. But then quite a good number of them haven't, because we need to have computers that solve problems better than the fastest classical supercomputer which we have now. Now, if we are to go to the slides where we are to see the companies and all what they've been doing. Yes, you can move on. Next slide, to the next, and next. Yes, we have quite a good number of challenges in quantum computing, but then we'll see which companies have been making progress, the strides that they've been making, and what is ahead of us. So, first off, we have HSBC, the Hong Kong and Shanghai Banking Corporation. Now, this banking corporation is looking at how to use quantum technologies to enhance their services and to also ensure the safety of customers' data. What happens right now is that quite a good number of threats, that is malicious actors, are gathering data, storing them, and just waiting for the time when quantum advantage is reached. Once quantum advantage reaches, that we have a viable quantum computer which can solve problems that classical computers can solve, that is breaking cryptography. Now, what happens is that these threat actors actually pick those data, decrypt them, and then use it for whatever they want to do. Now, over to the next slide, we have that of Google, and then we have that of their Willow chip. Now they're combining quantum with AI so as to ensure that they achieve quantum advantage and all of that. First off, they actually have the SEP, which is a Python library that is from Google. The next is Microsoft, and then one of the flagship chips, that is the Majorana one, which Microsoft has been able to work on, actually seems to be like it will be one of those first chips that will move us closer to quantum advantage, right? This chip is actually, that's based off what Microsoft said, right? This is based on topological qubits, And aside from that, it is less sensitive to noise, right? So at the end of the day, it will end up having much more stable qubits in there. Now over to IBM, that's the major company which has been making lots of strides in quantum computing. Over to the next slide, we have, first off, they have Qiskit, which is a very performant software stack for quantum computing algorithms. And second off is the Qiskit Advocate program. Now, with the Qiskit Advocate program, you can learn much more about quantum computing and also advocate for Qiskit and also about quantum computing in general. So let's go to the next slide. Next. Yes, how about you? Now, let's go to the next slide, and then the next. We have just two things here. First off is learning Python. Both Sec and Qiskit are both based on Python. And then the next bit is you could actually enroll for the IBM Qiskit Advocate program. And with this Advocate program, you get to join a community which helps to shape the future of quantum computing. Thank you. Yes, you can move on to the slides where you have just my socials. So you can follow me on LinkedIn or on Twitter. Thank you very much.